part 2, lesson 11. So under this lesson we have to understand with the notations, the SQL query language with the notation. Let's see here. We are going to discuss the relational algebra part 1 today. So under this lecture, you will be able to understand the relational query language as you have already knew about this one, the query languages, and I discussed 3 weeks before. And set operation, basically the query language depends on these set operations and unary operation, select and project, and not only these two, but we are going to discuss all the keywords and the relational queries using these set operations. So then what is relational algebra? So this is that mathematical model. Actually, relational algebra is a procedural query language. What is this procedural query language? Sometimes this word is new for you, procedural query language. So then procedural query language actually instruct the system to perform a series of operations. The user instruct to the system. That's the main thing you have to understand. The procedural query language, user instruct to the system to perform series of operation. In that operation, select the data set from the tables and select using a certain condition or any other to produce the desired result. So why you are going to use this one? To get the desired output. And here users tells what data to be retrieved from the database and how to retrieve it, so that you have to correctly instruct to the database what do you want and how to retrieve. So this is the main thing you have to understand under the relational algebra. When you compare the SQL queries, also you can see the select. What you want to select, you have to give the attribute list. Select name, address and telephone number. From where? From what? Then from the database names. Then you can give the condition where the city or the faculty equals ICT. Likewise, you can retrieve the information according to your requirement. You are not going to retrieve the information without any purpose. And if you write the commercial applications, database application, definitely you will have to retrieve this according to the requirement. Otherwise, no point of view of doing that one. The query you can write the query correctly, but you cannot get the expected outcome unless you plan the outcome, what you want and conditions that you have to use. The formal way to express the query in relational model, the formal way to express the query in a relational model using this one, you can use the formal way to express the queries. So what is that one? Query consists of relational expressions. You know that when you use the query, it will a relational expression describing the sequence of operations. It will clearly describe the sequence of operations. For an example, if you want to retrieve the output, actually you have to give the attribute names. Also, in the output, if you want a different name, you can put as likewise. And if you are going to combine 2-3 databases, in such case you can use this dot notation. S.student database, S.student from C.course. Likewise, C and S and C implements the student database and the course database. Likewise, I explain several techniques when you are going to retrieve. consists of relational expression describing the sequence of operation applied to obtain the query result. So, using that techniques, you will be able to retrieve and you will be able to write the what we call the clear queries. When someone read these queries, they will be able to understand what you have written. Otherwise, they may have some confusion because of your style. So that when you write the queries, you will have to practice the fashion of writing the queries. You have to be fascinated for this one, so that you can get you can clearly write the queries. It consists of a set operation. Actually, regardless of this set operation, you could write, but it consists of the set operation that takes one or more relations as input and proceeds to new relation of their results. So these operations actually, so the enable user to specify basic retrieval request. Normally we call the queries. Using this basic operation, the user will be provided, the user provides the facility to retrieve the result using the queries. And query languages actually allow manipulation, retrieval or data from the database. The query language you can understand, you can manipulate, allow to manipulation and retrieval of the data from the databases. So then I discussed deeply combining the multiple tables and ways, as well as what are the inner joins, outer, and also I discussed. So using these techniques, you can retrieve the required data from the database or the tables. Relational model support the simple, powerful query languages. Relational model actually supports the simple, powerful query language. This is because still the major commercial applications also use this query language. Actually, if it is a database application, definitely you can find some query languages to retrieve the data and prepare the reports. If you develop the commercial application, database application, you will have to write the complex queries to get the required output. The strong formal foundation based on logics. This is the reason of that one. It has a strong formal foundation based on the logics and allow for much optimization. You have to understand the query language is not a programming language. The programming language and query language is completely different. So query language use to retrieve the data from the databases or the data tables. The programming language you can embed these queries in the programming language. When you write the commercial application using a certain programming language, definitely you can insert the queries to retrieve the data. SQL is not expected to be turning complete, as well as SQL is not intended to be used for the complex calculations. So for the complex calculations, not intended to be used, so that SQL support easy, efficient access to large data sets. So this will provide the support for efficiently access the large data set from the required data set from the large databases. This is the main advantages you have from this relational query language. So then, two mathematical query languages from the basics, real languages for SQL and for implementation, relational algebra and relational calculus. You can find two mathematical query languages from the basis. of the real languages. That means SQL. The relational algebra also more operational, procedural, very useful for representing execution plans. And relational calculus, let's use describe this what they want rather than how to compute it. So non-operational and declarative things we can find this relational calculus. These two will be involved for these SQL query languages. So preliminaries, what are the preliminaries? Basic things that it needs. The query is applied to a relational instance, relational instance, relational instance, and the result of the query is also the relational instance. Relational instance means when you get the table, you can find the data. For an example, tuples, student table, which consists of the information about the student, name, address, telephone number, and faculty or any other information you can have according to the table attributes that in the table. So it is applied to the relational instance, and the result of a query also a relational instance. So from that relational table, you are going to extract the data. That the data is a subset of that when you get the one tuple. For an example, when you see one tuple means the row, and from that row you are going to get the retrieve the name, address, and telephone number of the student. In such case, having a large set of information in one tuple, you are going to extract the required information only. So schemas of inputs relational for query are fixed, but query will run regardless of the instance. The schema of the inputs relations for a query are fixed. You know that the schema has the name of the relation and also attribute names are there, or relation query are fixed, but query will run regardless of this instance. And schema for the result of a given query also fixed. When you retrieve the subset of that also fixed, determined by the definition of query language construct. So make sure that when you are going to give the attribute names, you will have to use the correct names similar to the tables. Otherwise, when you make a mistake, even in one single word in a one single letter in a word, you will be given an error message. Then you can't get the expected outcome. So the positional versus name field notations. Positional versus name field notation. Positional notation easy for the formal definitions. Name fields notations more reliable. So we'll explain later in detail what is the positional and the name notation, easy, and the name field notation. And both used in the SQL. Both these are used in the SQL. And next, set operations. You know that the in the mathematics, set theory is one of the famous one, and in the computer science, the set of theories will be used in many ways. The relational is relations in a relational algebra are set of tuples. You can understand when you get the table, the relation in a relational algebra, set of tuples means you can see when you create the schema. If you fill the data for this schema, then one row is called the tuple. Then you can get the set of tuples and in a relational table. So we can use basic set operation for that one. Set, mathematical definition for the collection of object which contains no duplicate. The set means, in the mathematical definition, collection of objects which contains no duplication. So which contains no duplication. That's why When the schema refinement process, we use the normalization to reduce or the redundancy of the data. The redundancy of the data means the same data cannot be seen in two places in the database. So this will actually support from that the normalization mathematical no collection of objects which contains no duplicates. So that this will support by the normalization. But when we refine the schemas, we have to consider this one. Elements, no duplicate elements, multisets equals bag, and no order among the elements. But you can find some ordered set, and also the subset also we can find. And the proper subsets, supersets, union, intersection, set different, and Cartesian product also we can find. The element of the set operations, once again I will explain. No duplicate elements, as I explained. No order among the elements, also. This we can find subsets, proper subset, supersets, union, intersection, set difference, and Cartesian product. Set different and Cartesian product also we can find. Also, the fundamental operation in a relational algebra are the fundamental operation. These are similar to the some of these are similar to the SQL keywords also. Select, project, union, set different, Cartesian product, and rename. So some of most of all of these are can be found in SQL also. The select, project, and rename operation are called unary operations. The select, project, and rename, these operations are called unary operations. Why? Because they operate on one relation. The unary operation means they operate in one relation. You can select name, address, telephone number from student. Then you can use the one relation. You can use the one relation for that one. The project also rename we can use. But the other three operations operate on pair of relations. They are therefore called the binary operation. For an example, the Cartesian product and set different and union. The Cartesian product, set difference, and union. So this operates on pair of relations, and they are therefore called the binary operation. Minimum of 2. Yes. So there are groups of relational operations. Relational database operation. These are the relational DB operation. Select, project, join, rename, union, intersect, set different, Cartesian product. These are the relational database operation. And so we can find some notations for this relational database operation. So here you can find operation, the symbols, projection, project. The keyword is project. Actually, we use the phi. This symbol is called the phi. And selection, the select. Select, actually, this is the one of the famous keyword we are using, and this is called the row. Rename, sigma, actually. This is sigma, and rename is the row. Union, keyword also the union. You can see U. Intersection, actually, you can find like this. The assignment, normally we use this one. You are going to assign to a certain name. The output is assigned to a certain name, you can use this left side arrow, and Cartesian product normally use the X or the cross. Join we use this one, both sides are closed. This is called the full join. Full join, you use both sides are closed. Left outer join, the left side only open, the right side must be closed. Right outer join, left side must be closed and right side must be open. Full outer join means both sides must be open, and semi join, you can see left side is closed and other side open. So most of these notations are very, very important to understand, and also those notation must be kept in your mind. You have to keep this in your mind. The project, select, rename, union, intersection, and assignment, Cartesian product, join, left outer, right outer, full outer join, likewise. We'll try to practice. First of all, I'm going to get the easiest notation, the select. Normally we can use this symbol row and selection criteria, and you have to give the inputs. The selection operator specifies the tuples to retain through selection criteria. The selection criteria, you will have to give the attributes that you want. Manipulate the relational single relation. And inputs are the relational instance. This is the table names. This you have to give the table name here. And relational instance input is the relational instant. Relational criteria means a Boolean combination using the and or of terms. Actually terms are the attributes. OP consists of attribute 1, OP attribute 2. The operations are greater than or equals, not equals, less than or equals, or less than. These operators can be used for this selection criteria, so that you have to understand the combination of this one. This inputs the operation specifies the tuples to retain through the selection criteria. Select what are the tuples you want in the selection criteria. Selection criteria is a Boolean combination. And then terms, what are the terms? Are the attribute of constant, O attribute 1, OP attribute 2. The condition that you have to give using these operations. OP is the operation. These are the operation OPs that can be used. We'll try to practice an example. Select symbol sigma. Select a subset of rows from relation. Select operation, select condition used to select the subset of tuples from the relation that satisfy a relational condition. We'll see. The selection condition is a Boolean operation with a set of clauses as below connected by AND, or not Boolean operation. OP is AND, or not. A operation B, where A is an attribute of the input relation, B is an element of an attribute of an input relation consistence. OP is this one. Actually, this also a explanation of this one. Okay. We'll try to do the example. Select all from S, where rating is greater than 8. We have a certain relation S, student ID, name, rating is there, and age. Rating is greater than 8. How can we write from the these notations? We can write, I will give you 2-3 minutes. Try to write using the symbols. Then we can see whether it is correct. If you have a piece of paper and with the pencil or the pen, please try to write the notation for this one. Select all from S where rating is greater than 8. So in that time you have to get the 9, only 9 and 10 tuples, 28 and 58. So how do you write? I will give you 1 minute for that. I will give you 1 minute. Okay, that's enough. You can write like this. You want to get the output as this. Then how do you write? Select command is this one, and you haven't given this one, and S, from S. Select all from S is the relation name where rating is greater than 8. This is the condition you have to give. Rating is greater than 8. Very simple. Rather than writing this one, you can simply write like that. Okay. Let's try another one. So, computer science student with GPA greater than 30. The computer science student, select the computer science student with GPA greater than 3.0. You have this one, computer science student. So the major is computer science, ne? So how do you write it? Think. Select star from student where major is computer science and GPA is greater than 3.0. Both condition must be satisfied. Both condition must be satisfied. In such case, how you have to use the O operation. So select all from student where GPA is greater than 30 and major is CSE, computer science. This is the query language. How do you write using the set notations? You can write select all from student, then within this one you can give the GPA is greater than 3 and major is SCE, computer science. Okay. Let's try to project. Project symbol is called the phi. Select columns from the relation. So you can see the project, you are going to select the columns, that is attributes. The project phi attribute 1, attribute 2 and attribute n operator selects attribute specified in the attribute list of the inputs relation and discard the other attributes. So we'll see. Select name major from student. You want to get only the name and major from student relation. In such case, you can write phi name major from where? From the student. Then you can get all the names and major of the student relations saved in that table. Okay. Next. So duplicate here in this case, duplicate rows are eliminated. If there are any duplicate rows, it will eliminated, not in use. Not like the SQL language. And given list of column names A and a relation R, extract the columns from A from the relation. For an example, you can write roots, root ID, root name, grade, rating and height. So you want to get only this one, RID and height, RID and height from this one. You can write project RID and height from roots. Simply you can get like this. And so here suppose that the result of the projection has repeated values. How do you if there are some repeat values, you want to get the answer this one. How do we react it? So 5 height roots, so that answer 1 and 2. In pure relation algebra, the answer is always a set, the second answer. In a pure relational algebra, actually, you can find this one. However, the SQL, when you write the SQL query and some other languages return by default in the multi sets, you can find the answer 1 in the SQL. But in the pure relational algebra, you can find this one. The repeated or the sets will be highlighted, then only you can find ones. Once again, another example, the student table. Find the names and rating from S of all soldiers. Let's see S name and rating from S. You can find you can get like this. Find the age of the soldiers. Age of the soldiers. Here you can find like this. Only in such case 35, 55, 35, 35, only you can have 35 and 55. Not the you can get the unique one, 35 and 55. That is the difference between the SQL and this is set operations. So example, several operations can be combined from the relational algebra expressions. Several operations can be combined. The retrieve the names and the rating of the soldiers where rating is more than 8. Names and the rating you want. Where the rating is greater than 8, that you can get only these result. In such case, this is the rating is greater than 8. Select rating is greater than 8. So you can get the select operation, and only if you in that such case it will give all these 4 attributes, 4 columns. In such case you want to get the name and the rating, so that you can combine with the 5. Okay. So the 5 S name and rating, you want to get only these 2 from where select rating is greater than 8, so that project and select operations combined together in order to get this one. So that's why several operations can be combined from the relational algebra expressions to get the required query. In select operation you can get all the attributes, but if you want to limit, you have to use the project. The rename. Next one is rename. Rename operation, actually normally called the row, rename the input relation and the attributes with a new name, new relational name and attribute specified. So in our SQL we use the as name as soldier name. Likewise we can use here in this case we can use the temporary relation. We can create assign them to the temporary relation, and then temporary relation can be renamed. For project name major from the student and assign that relation to the temp. Then project student info full name and M department from the temp. Then this one can be renamed by giving your name, row student info. Rename the student info and full name instead of this name, full name, and major also M department, major department. And then you can first of all assign to the temp and rename the temp. This is the way to rename. So union compatibility. If you want to combine two relations, it must have a compatibility. This is called the union compatibility. The union compatibility, two relations are A1, these are the attributes to N, S, B1 to Bn are said to be union compatible if they have the following characteristics. One is degree of the relation R and S are equal. Degree of the relation, you know that the number of attributes. And if domain AI equals domain BI, domain AI and domain BI must be same. For one, that is called the corresponding fields of R and S taken from the left to right have the same domains. So if the domains are different, it cannot be done. So that these, another one, those are the main two characteristics if you want to union or combine two relations together. So this is the end of lesson.